So you should have just finished watching the video where we went over the first goal, recognizing an exponential function. The purpose of this video is to really cover both of the goals 2 and 3. We're going to look at them together. So just to make sure we've got it, these goals are: 1, recognizing whether an exponential function is of exponential growth or exponential decay, so growth versus decay, and also being able to graph the exponential function. So let's take a look at how an exponential function works. Let's say we'll start with a relatively basic sort of exponential function. Let's take f of x equals 2 times 3 to the x. Notice the x in the exponent. That input is in the exponent. Now, to understand this, we can look at inputs and outputs. So our input is x, our output the f of x, right? What comes out of this function? Let's put in a few values. We're going to go -2, -1, 0, 1, 2, and let's go all the way to 3. So I'm actually going to start here, I'll start right here, and we'll then fill in the rest. So f of x, let's see if I'm going to think these through. You can do this along with me. It's good to think as I'm thinking, right? Don't just write down what I'm saying. You should write down what I'm saying so you have it in your notes, but try and think ahead. Okay, so if the input is 1, 2 times 3 to the 1, that's going to be 6. But what if the input is 2? So my function rule is 2 times 3 to the input. In this case, the input is 2. So what does this mean? This means 2 times 3 times 3, because the exponent is referring to the 3. So it's 2 times 3 multiplied twice, 2 times 3 times 3. So that's going to be 18. Okay, I'm going to pause for a moment while you think about what if the input's 3? What's going to go here? So you're thinking this through right now. I'll give you 5 more seconds. Okay, so you should have something like this. 2 times 3 to the third. So that's 2 times 3 times 3 times 3. This is 27. 3 times 3 times 3. So 2 times 27 is 54. Alright, so I've got some of this filled out, and meanwhile I might draw a little graph. I'm just going to sketch this. So I'll go 1, 2, 3 in that direction, and there's my 0, and I'll go -1, -2, since that's on my table. And let's see, I have to go all the way up to 54. So let me go, while this is going by ones, I'm actually going to go here by tens. So 10, 20, 30, 40, 50. Obviously just a sketch, but it'll give us an idea. All right, before we fill that in, let's fill this one in. So let's see, 2 times 3 to the 0. Well, when we ask what's being raised to the 0, it's just the 3. 3 is the base. So it's 2 times 3 to the 0. 3 to the 0 is 1. Any number raised to the 0 is 1. So this is really 2 times 1. Oh, okay, so 2. Now, let's start graphing some of this before we go backwards and do those two. Let's see here. So 0, 2, that's right here. 1, 6, 1, 6. Let's see, that's going to be about right there. You're doing this along with me right now. Let's see, 2, 18, so that's going to be like right there. That's sort of an interesting shape. So clearly not a line. Maybe is that too high? There we go. And 354. So 354. Huh. Okay. So if I had to draw, probably something like this, right? Now, let's make a prediction about where this might go. If you had to keep trying this, where do you think it goes? Is it going to go under the x-axis? Is it going to stay above the x-axis? What will it do? All right, let's take a look. So, -1. So 2 times 3 to the -1. Oh boy, now we got to remember about that whole idea that when something is raised to a negative exponent, what does that mean? That's right. It creates that reciprocal. The idea of a multiplicative inverse. A multiplicative inverse. So that means like 3 to the -1 equals 1/3. Because 1/3, and the reason was 1/3 times 3 is equal to 1. 1/3 times 3 itself is equal to 1. So these two are multiplicative inverses. All right, so this means that 2 times 3 to the -1, 3 is being raised to the -1, so this is 2 times 1/3. 2 times 1/3. That's what that means. Okay, so that is 2/3. And here, this is 2 times 3 to the -2, which is 2 times, again, you got to take that reciprocal, 1 over 3 squared. The negative in the exponent means you're creating that reciprocal, a very important point. All right, so 2 times 1 over 3 squared. 3 squared is 9, so this is 2/9. Let's go back to our graph. Now in your head, you've predicted where this shape is going to go, right? So let's see if this information helps us. 2/9. So let's see, 2/3. -1, 2/3. Okay, it's going to be like here, still positive, like there. 2/9 is a little smaller, but still positive. Huh. Looks like it's not hitting the x-axis, and in fact, it doesn't. It never touches the x-axis. It gets really close in this direction, but doesn't touch it. And then look at this, shoots way up there. This is exponential growth. Exponential growth. All right, now you can tell it in two ways. One is the picture. Take a look at this. Talk about growing for bigger and bigger positive numbers in your input. Wow, does this get big? You can imagine if your input were like 4 or 400 even, how huge the output would be. The output continues to grow and grow and grow and grow and grow and grow. Okay. So that's, one way to spot the growth is this shape. The other is right here. The base is greater than 1. Base is greater than 1. So, I'm going to write B is greater than 1. The base is greater than 1. So, when you multiply whatever the number was, in every case you started with a 2, then we multiplied it by something. Well, if you're multiplying by something bigger than 1, it will grow and grow and grow and grow and grow. All right, so those are your two keys. And knowing these two keys will help us when we do exponential decay. Here we go. Let's look at decay. So if the base being greater than 1 gives you exponential growth, base being less than 1 will give you decay. Let's take a look. G of x equals, let's keep the same starting value, 2. But this time we're going to do 1/3 to the x. This is going to give us exponential decay. Now let me stop right now and point out what some people get confused on. Some folks might think that this number, this base needs to be, the base here needs to be negative to create exponential growth, and that is not true. I wrote growth, decay, excuse me, sorry. Exponential decay. So here we have exponential decay because the base is less than 1. I apologize. And some people think that you have to have a negative base to create exponential decay. But that is not true. If this was a negative base, some weird things start to happen. So we're only going to deal with positive values of the base. All right, but what's important is that the base is less than 1. It's also, by the way, greater than 0. Okay, so it's these fractional or decimal values between 0 and 1. Let's take a look at the table. So again, we'll look at -2, -1, 0, 1, 2, and 3. And then look at the outputs. So we'll start with this one. Let's see, so 2 times 1/3 to the first power. So that's simply 2/3. Here we have 2 times 1/3 to the second power. So that's 2 times 1/3 times 1/3 again. That's going to be 2/9. Notice the output getting smaller. 2 times 1/3 to the third is 2 times 1/3 times 1/3 times 1/3 again. So what's happening? If you multiply by a small number less than 1, again, you're going to get an even smaller number. That's what happens when you multiply by a number less than 1. The number itself gets smaller. So here you have 2 times 1/3 times 1/3 times 1/3. This is going to be 27 down here. So 2/27ths, a smaller number. All right, so output's getting smaller. 2 times 1/3 to the 0. Any number to the 0 is 1. So that's 2 times 1. Okay, 2. 2 times 1/3 to the -1. The -1 in the exponent means to create a reciprocal. That negative in the exponent means reciprocal. So this is 2 times the reciprocal of 1/3 is 3/1. So 2 times 3, oh, that's 6. Notice as we go backwards, the numbers are getting larger. Okay, 2 times 1/3 to the -2. That's going to be 2 times, making my reciprocal because of the negative exponent. So 3/1 squared, 2 times 9. 2 times 9. Okay, that's 18. So when we go to graph this, just sketching it out, there's our 1, 2, 3, -1, -2. We'll again go by, let's go by, sure we can still go by 10, so 10, 20, that should be enough. Let's go back here, so -2, 18, we're just sketching, -1, 6, 0, 2, 1, 2/3, oh, they're getting really small, but they stay positive. Notice again, it does not hit the x-axis. It gets really close to it, but it doesn't hit it. Look at that. So I create this arrow showing it that the graph continues this way, never hitting the x-axis, which is kind of a crazy thought. Just the numbers get smaller and smaller and smaller and smaller, but theoretically, man, the output never hits 0. Okay, and that's exponential decay. So now you've hit your 2 goals. You should be able to recognize whether an exponential function is of growth or decay by either looking at the shape, one of growth or decay, or you can look at the base. If the base is greater than 1, you have growth. If it's less than 1, but remember greater than 0, then you have exponential decay. The second goal is you can graph an exponential function, and you can do that now, right? You just create the table, and from the table you can create a graph. Thanks very much for watching and for taking good notes. See you in class.